Good evening everyone. I hope you all are doing great. So in this tutorial we are going to do some machine learning things. Okay, and we are going to develop a model which can help a submarine predicting whether it's a rock or a mine in its path. Right, so let me just show you the data I have with me through which I'm going to train my model. Okay, so you can get it from an open source website like Kaggle, and there are a number of websites. If you know about machine learning, so you must be knowing about those websites also from where you can get this type of data. So basically it's a Excel file, and I have this comma separated values inside it. So let me just open it and show you what we have inside this file first before we proceed to the next step. And if you want to learn machine learning concepts like artificial intelligence, game development, mobile application development, data science, computer vision, natural language processing, website development, web application development, then you can take my courses. Okay, you can ask your parents to get in touch with me. My number is getting reflected right now on your screens, so you can get in touch with me on this very same number. I'm on WhatsApp also on this number. So in case you want the coding classes, you want to avail the coding classes which I offer to the students, you can surely get in touch with me on this number below. So that's the data we have in this CSV file, and in total we have 60 columns in it, and in the last column the result is there. So R here refers to rock, and let me just come down, and then we have some M's. Okay, so M here refers to mines. Okay, so now we'll be using this data for training our model, and how to train the model, how to test it, then how to evaluate its performance, and then how to use it. That's what we are going to learn now. So we'll have to first upload the data. For doing that, okay, I need to, I think, refresh Google Colab's notebook. I hope you guys know about Google Colab. So it's an online platform basically, and it's very efficient. So you can use it for all the types of machine learning project and artificial intelligence projects. Definitely it will give you a very good result. You're going to enjoy this platform a lot. If you haven't tried it out yet, please go ahead and do try it out. Okay, so right now I think Python 3. Okay, now it's connected. Fine. So now we can upload the CSV file here. Just give me a short moment. So let's upload that file which I just showed you. So it's there in grade 10 named folder and ML projects. That's where my file is, sonar data. Okay, so I've successfully uploaded the file, and you can see the file is now getting reflected here. Okay, so the first thing we need to do is we need to import all the libraries and all the functions we need to use for this project. We'll be using for this project. So the Numpy we'll be using for converting the data into Numpy arrays. Then Pandas we'll be using for reading the data of present in this CSV file. Then that's the function that we'll be using for splitting the data into training and testing set. Logistic regression is the model we are going to use for this project, and then accuracy score we'll be using for finding out the accuracy of the model, means for finding out, for evaluating the model basically. So let's execute all these commands. Okay, so they got successfully executed. Let's hit this code button for creating a code window. Okay, now let's come on this line of code. So this will help us in reading the content which is present in this sonar data.csv named file. We do not require content. Okay, let's execute this file. So this command also has been successfully executed by Google Colab, and now all the data we have in this sonar data.csv named file is present in this variable named sonar underscore data. Okay, now if suppose you want to pull the data, you want to suppose check out the first 5 rows of the tabular data present in this variable named sonar data. So you can use this function named head. So it will give us the for the data present in the first 5 rows. As I've told you, that's the data we have received from this line of code. Okay, let's create another coding window. Fine. Let's come down. Let's try to find out the shape of the data we have in this sonar underscore data named variable. So for that, shape is the function we can use. So it's a matrix of 208 by 61. Why it is showing 61 here? Let me tell you that. So the index number starts from 0, is starting from 0 and it's ending at 60. So in total there are 61 columns. That is the reason we are getting 61 here. And in total there are 208 rows, and so this is row and these are the number of columns we have in the CSV file. Let's create another coding window. Now it's time for us to check the description. So describe is again a function through which we can do it. Let's execute this line of code. So you can see it has given us almost everything we require for our model, for our data. So it has given us the count, it has given us the mean of the data, it has given us the standard deviation, then minimum value 25%, 50%, 75%, then maximum values. So that's the function with the help of which you can find out all these things. If you know about machine learning, definitely you must be knowing about this describe function also. If you don't know about it, you can take the coding classes. Definitely you can contact me on the number which is getting reflected on your screen right now. Just give me a call. I will definitely help you with all the information of all the courses which I am right now providing to the students. So it's time for us to now check the values, check the count of the values. So let's execute this line of code and see what it will give us. So it has given us this as output. So it is telling us that there are total 111 number of examples of mines, and there are in total 97 examples of rocks present in the data. So that is how you can find out the counts. Okay, let's come down and group the data now. So again we need to create a coding window. So that's the function with the help of which you can group the data and you can find out the mean also. Okay, so we have successfully grouped the data into two categories, mines and rocks. Fine. Now let's come down and let's execute this code. So what we are doing here, we are going to take everything which is present in the variable named sonar data. So whatever is there in the CSV file, it is right now there in sonar underscore data also. But we do not want to take the 60th column, okay, in which the labels are present, RM, right? So we do not want to take it, we want to drop that. So for dropping that column, we have used drop function here, okay, and then we would like to take that 60th column in some other variable. So y we are going to take all the labels, and in x all the features will come. These numbers over here are representing the features. Okay, let's execute the code and see what it will give us. Okay, so the code executed successfully. Let's create a coding window and let's print the value of x and y. I don't think we have the code for it over here. No problem. Let me just type it manually. So print x. Let's see what we'll get. And also I would like to see the thing I have in the variable y. Okay, so let's execute these two lines of code, and that's what I'm getting. So, all these features you are seeing over here in the form of numbers, they are present in variable x right now, and in y we have the labels. Fine. Okay, let's go back and let's now copy this code and execute it here. So what this code will do for us, let me just tell you that first before executing it. So we are right now splitting the data into two parts, training data and testing data. With training data, we are going to train the model. With testing data, we are going to evaluate the performance of the model. Right. And why it's written test size is equals to zero point 0.1 here? Because we want to have 10% of the total data as the testing data. For example, if suppose you have let's say 200 entries in the table, 200 examples in the CSV file. So 10% of 200 is 20. So 20 examples we are going to take for testing the model, and 180 will be using for training the model. That's what it means. So we have used four variables here. The first one is xtrain, in which all the training data will come. Right, then we have x test. So all the features with which we'll be testing the model will go here in this x test. Then in Y train, the labels with which we are going to train the data will come, and in Y test, the labels with which we are going to test the data will come. Right, let's execute this line of code and see. Okay, so it executed successfully. Let me now show you the shape of x train and x test. So we have now three variables. One is this x, which we created here, right, in which all the features are present. Then we have something called x train, right, which we used here. Then we have something called x test, which we used here. Okay, let's see what do these three variables have in them. So we'll have to execute this line of code first. Okay, so the shape of x is 208 by 60, right? Out of 208, 187 we are going to make use of as a training set, right? And 21 examples we will use for testing the model. So this is what is the current scenario. Now let me print the value of x train and y train and show you what we have inside these two variables. So let's run these two lines of code, and in x train we have these features, and in y train we have these labels. So we are going to train the model with labeled data. So I hope you guys know about the two types of learning, supervised and unsupervised. In supervised learning, we use labeled data, and in unsupervised learning, we use unlabeled data. So here we are going to make use of supervised learning. So let's first create a model. So we are going to use logistic regression model here, and let's execute the line of code. Okay, so now we have created a logistic regression model which is present in the variable named model. Okay, let's create a coding window here and let's come down. Now it's time for us to train the model. So we have a function called fit, with the help of which we can train the model. So we are going to train it with the features along with its what we call it labels. Let's execute this line of code. So we have successfully trained our model. right? We have successfully trained our model. Now it's time for us to check the accuracy on the training data. So this is the line of code that we can use for that. Okay, so here as you can see, we have used a function called predict first. So it will be, see, we have already trained the model using the training data. Now we are giving it some data again for predicting the labels for this data. Okay, and then using this accuracy score, we will see how accurately it has predicted for us the output. Right, how accurate the output is which the model has given us. So that's what we will check with the help of accuracy underscore function. Fine, so we are still using training data. We haven't used testing data yet. Let's execute the code and okay, so the code executed successfully. Let me just see the accuracy of the machine on training data. So it is 0.83, so it's 80, its accuracy is 83%, so it's not bad, it's extremely good. Let's create another coding window, and now it's time for us to check the model on the testing data. So earlier it was x train prediction, y train, and now it is x test prediction, and y test. Okay, so the model doesn't know anything about this data, right? We trained the model on the training data, and then we tested it on the training data only. But now the data we are using for testing the model, it's completely unknown to the model. Let's see what it will give us as an output. So the code got successfully executed. It's time for us to print the accuracy of the model. So that's the line of code we can use for doing it. So the model is has given us a result which is 76% accurate. So if the accuracy is more than 70%, it means that the model is fine. It's good to go. We can deploy it in the environment we have created it for. So it's working perfectly fine. Fine, now let's check the model for some random data. So for that, let me just copy this entire code and let me put it over here. Okay, so what I'll be doing now, just a second. I need to copy this code also. Yes, only this thing, not this code. I'm putting it right on the top over here. So let's first open the CSV file in a notepad and see what kind of output we'll get. So in the notepad, its view is somewhat like this, right? Let me enlarge the size of the window of notepad. Okay, so in the very first row, if you will see, it's it's for R, means these features which you are able to see in the first row, it's for a rock. So let's copy all these features and let's pass them to the model as input data. Fine. And now what we are doing, we have used this function named as array for converting the data into an array. Fine, and then we are reshaping the array, which is also again very much required. Then here we have used the predict function that we used here, right? So as to make the model predict something for us based on the data we have inputted here. Then we are printing the prediction. Now if the prediction is equal to R, then it should give us the object is a rock. Otherwise it should print for us the object is a mine. As you guys know, the data which we just copied, it's for a rock, right? Let's see whether the model will be able to predict for us the correct out, whether the output which the model will predict will match with this over here or not. So I'm running the code. Okay, so its prediction is absolutely correct. So it's a rock, the data of which we just inputted as to this model. Now let's select something else. Okay, let us go with this data, these features we have in this file for a mine. So I'm going to paste it over here. Perfectly fine. Now let's execute the code and see. Okay, so now again its prediction is correct. So it's a mine. Fine. So the model is behaving perfectly fine, and that's the way we can create a model, we can train it, and we can test it. Okay, so this is the this is what a machine learning consists of. Collecting the data, then splitting the data into testing and training data, then creating a model. Then we need to train the model using the training data, and once we are through with training the model, we need to evaluate its performance. So there are a number of functions like predict, fit, right, with the help of which we can train the data, we can make the model, we can train the model, and we can predict, we can ask it to predict something for us. And after that, there are functions with the help of which we can check the accuracy of the model, right? I hope you guys enjoyed this lecture a lot. If you need any help, you can contact me on the number which is getting reflected on your screen. Okay, and for the coding classes, you can ask your parents to get in touch with me. Definitely, you are going to take away many things from the coding classes which I'll provide you. Thank you so very much for supporting my channel, for liking and sharing my videos. Have a great day. Bye bye and take care, everyone.